Let's start our NCERT class. This is on geomorphology. Before stepping into geomorphology, we must understand what is geography. And before understanding geography, we must understand its definition over the period of time, how it has changed. Now, this is planet Earth, part of the solar system, and it's the fifth largest one. It's a terrestrial planet. It has the maximum density. And it's having different layers. It has core, it has mantle, it has crust. And the geography is, and this is what the surface. And the geography is the study of the surface of Earth as a home of man. Before that, what was the geography? It's the description of the Earth, maybe as a habitat of the man, of the human beings. Thereafter, interior part has gone to the geology, geology, geochemistry, geophysics. And the surface of Earth, that is a visible part of the crust, that has turned out to be geography. Geography is the study of the surface of Earth as the home of man. Then came a special era in almost all the disciplines, in geography also, and that was of quantitative revolution from 1930 to 1965. All the people started synthesizing the subject into minimum words, incorporating polynomials, equations, sequential progressions, algorithms, and it has turned out to be scientific study of organization of spatial phenomena expressed as patterns and processes. See how the concept had changed. Organization of spatial phenomena. Spatial phenomena. Expressed as patterns and processes. All the processes that are responsible for the development of the patterns. Now, if we see the distribution of the mountains, maximum of the mountains are on the western margins of the continents. Maximum. Whether it's Atlas Mountains, whether it's the Rockies, it's Andes, it's the Scandinavian highlands on the western margins, or on the margins of the subcontinents, like Himalayas on the margins of the Indian subcontinent, Great Dividing Range on the margins of Australian continent. So these are the patterns that we have to understand it. So geography turned out to be, after 1968, scientific study of organization of spatial phenomena expressed as patterns and processes. एक बात आप याद रखना कि जो रियलिटी है उसके ना तीन एस्पेक्ट हैं, हिस्टोरिकल प्लस ज्योग्राफिकल प्लस साइंटिफिक, chronological, spatial and analytical. तब जाकर आपकी रियलिटी कंप्लीट होती है. ये स्पेशल एस्पेक्ट है. दिस इज वन ऑफ द थ्री एस्पेक्ट्स that constitute a reality. One of the three aspects of reality, that is the spatial phenomena. that always happen at a particular time. And when these phenomena occur after the specific times, then they emerge as patterns. That's what the geography is. Now let's understand it. How many parts of the geography that we people do? We do 8 parts. We do 8 parts. Geomorphology, the study of landforms. Climatology, the scientific study of the climates, the factors of climate, the controls of climate. Oceanography, the study of the oceans. What is the definition of an ocean? 3% of the water surface and 3 layers: epilimnion, thermocline, hypolimnion. So that water body will be called an ocean. It must have a specific benthic surface and it expands from the continental threshold from one end to the continental threshold onto the other end. Geography of India, 4th part. Solar system, 5th part. Time calculation and calendars, 6th part. Human geography, 7th one, and disaster management, that is a part of paper 3, GS paper 3. So all these things constitute geography. And geomorphology is one such segment of geography that we are going to do. So let's see what exactly we are having in geomorphology. So what is the scope of geomorphology? The very first thing, we must understand the geological time scale. Geological time scale. That is geological time scale. What does it mean? How many super eons we are having? Eons we are having. It is something that divide like this. Super eon, eon, right? We have eras, periods, and we are having epochs. We have ages, chrones, like this. That's a geological time scale. At this moment, we are living into the Meghalayan age that started 4,200 years before present, with a part of the Holocene that started 11,800 years before present. Right? And we are the part of the Phanerozoic eon that had been further divided into the Paleozoic, Mesozoic, and the Cenozoic. And Cenozoic into several parts, like the Tertiary period and the Quaternary period. And Tertiary period has been divided into 5 epochs, and the Quaternary period has been divided into 2 epochs. The last one was the Pleistocene, and the Holocene is going on. And the Holocene is having so many of the ages. We are at this moment in the Meghalayan ice. That's a geological time scale. That's the first part. Those who had already done with me, it's okay. Those who are not done, we'll repeat it. Got it, Vachi? The very first thing is geological time scale. And the second one is definition of geomorphology. Definition. Third one is forces. How many types of forces we are having? That diagram that we have to draw today, this is basically the syllabus of geomorphology. Then we are having seismic seismology. Then we're having volcanicity. We study earthquakes here, we study volcanoes here. Then we're having interior of the earth. How many layers we are having? Very recently, we had found the innermost core. Now we are having three layers of the core: the outer core, the inner core, and the innermost core. And we are having now the six discontinuities: the Conrad, the Mohorovicic, the Lehman 2, Rapiti, Gutenberg-Whitechurch, Lehman 1. So, expanse of knowledge, they are increasing day after day. Now, this is the interior of the earth, and this is the hotspot. Then we are having the study of landforms. 7 types of topographies are the part of our syllabus. What type of topographies are there? We are going to see during the forces diagram. We are having plate tectonic theory. Plate tectonic theory. And we are having continental drift theory. Continental drift theory. First we'll do continental drift theory, then we'll go ahead with the plate tectonic theory. Then we're having the comprehensive study of rocks and rock cycles. So these are the very broad things that we are supposed to fix it up. And to some extent, we study the geosynclines also there. Because these geosynclines are helpful in the understanding of mountain building, the fold mountains especially. Plate tectonics helps us in understanding the formation of the block mountains, the rift valleys. Besides that, we are having a comprehensive study of folds and faults. Folds and faults. This is the immediate syllabi of geomorphology. Right? Let's see how many parts we have to cover. This is the geological timescale part 1, definition of the geomorphology part 2, forces part 3, seismology part 4, volcanicity 5, interior of the earth 6, geosyncline 7, landforms 8, plate tectonic 9, 10 is the CGT, rock cycle is 11, and 12 is fold and fault. We are having 12 topics. Each and every topic is very exhaustive. You will say that we are doing volcanicity and the seismology, why we are not doing the tsunamis? Tsunamis we cover in the oceanography. We have covered in the oceanography. Those who have not done oceanography, they will do it there with me. For the time being, we are going to focus on these 12 topics, and we are starting with the definition of geomorphology. Now, this is geomorphology. Let's first divide this thing etymologically. Geomorphology, the scientific explanation of the landforms on the surface of Earth, of the planet Earth. That's geomorphology, that is etymological definition. Now let's come to the second definition, that is more scientific. We are having 2 types of forces. the interior forces, the endogenetic forces, and the exogenetic forces, the exterior forces, the epigene forces, and the hypogene forces. And these forces interact. Out of their interaction, we are having various types of landforms. The study of interaction of endogenetic forces and the exogenetic forces and the resultant landforms is called geomorphology. Scientific study of the landforms of the planet Earth is called geomorphology. That's the definition. Let's understand it again. First, we will see this is Earth. These are the landforms. That's the scientific explanation, the logical deductions and inductions. The second definition is there. It's a systematic study of interaction of exogenetic forces and endogenetic forces. You can write endogenetic as endogenic. You can write hypogenic, hypogene. It's up to you. Exogenetic as epigene, exogenic. It's okay. We have the British versions and the American versions. But that's the definition, interaction of the endogenetic and the exogenetic forces and the resultant landforms is geomorphology. The scientific explanation, scientific study. And somewhere now we also study the patterns and the processes responsible for it. What are the processes? These endogenetic and exogenetic forces. What are the patterns? These are the emerging patterns of the landforms. How they are distributed? Between the two mountain systems, we are always having an in-between area, that is a median mass. It may be a plateau, it may be plains, it may be the water body. In between Apennine mountains of Italy, Dinaric Alps of former Yugoslavia, and the Alps mountains of Italy and Switzerland, we are having Adriatic Sea, a water body in between. Between the Himalayas and the Kunlun, there is a Tibetan plateau. Between the Pontic and the Taurus mountains of Turkey, we are having plateau of Anatolia. Between the western mountain range and the eastern mountain range that we call Sierra Madre, Occidental and Oriental of Mexico, we are having Mexican plateau. All these landforms are having specific distribution patterns. Just see the Great Dividing Range of Australia. It is on the margins of the continent. You look at the Himalayan mountain system. It is on the margins of the Indian subcontinent. Look at the Rockies on the margins of the North American continent. Look at the Scandinavian highlands, the Cajular Mountains on the margins of the Scandinavian peninsula. Look at the Andes on the margins of South American continent. There are the patterns. And the study of such patterns and the forces responsible for the development of those patterns of the landforms is nothing but the geomorphology. Mountains, plains, plateauics are the second order landforms. Alluvial fans, deltas, floodplains, natural levees, riverine islands, beaches, stumps, arches, cliff, all these are the third order landforms. Geomorphology is having three orders of landforms. The larger continents and subcontinents, these are the first order. Mountains, plains, plateaus, second order. And the third order are the landforms of local importance. Some waterfall, some cataract, some escarpment, overhanging wall, V-shaped valley, U-shaped valley, Paternoster Lake, Ribbon Lake, Tar Lake, TARN, some cirque, CIRQUE, armchair-like depression along with the mountain systems into the glaciated areas. All these are the third order landforms. The study of first order, second order, third order landforms is called geomorphology. So these are the definitions that you can write. You listen it again and again, you'll be able to work out a very good definition there. Now let's come to the last part of the geomorphology that we have to cover today. And this is the forces, and it's going to be the 2 pages diagram. Forces. We are having 2 types of forces. We are having endogenetic forces. And we are having exogenetic forces. And this diagram will go up to the 2 pages. You draw this diagram on the 2 pages here. We have to complete this diagram. Now here we have 2 types. These are the extraterrestrial forces and these are the terrestrial forces. These extraterrestrial forces may be some meteorites, meteoritic ash. Some meteorite is falling on the surface of the earth and is creating an impact lake. There are 200 meteoritic impact lakes. Here in India, we have a huge impact lake in Maharashtra, Lonar Lake. Now, this is what the extraterrestrial forces, we talk less about it. One thing you have to keep in mind, when the planet Earth was having thin atmosphere into the beginning, most of the meteors were reaching the surface of Earth and having an impact as the meteoritic, as meteorites. And do not forget the definition. Any object that passes nearby the planet Earth does not enter into its atmosphere. It is meteoroid, D. Meteoroid. That enters, it is meteor. And that hits the surface of Earth, that is meteorites. And the things which burn to the ash and then ash also settle down, that is a meteoritic ash. They have an impact. Why? Because every second we people receive 10 kg of the extraterrestrial material on the surface of Earth. Now let's come to the terrestrial forces. Exogenetic forces. These are 7 forces we are having. Running water, rivers, glaciers, ice sheet, groundwater, winds, sea waves, human beings. These are the 7 terrestrial forces which are exogenetic. Exogenetic. terrestrial exogenetic forces. 7. Running water, river. It makes fluvial topography. Glaciers make glacial topography. Ice sheets make periglacial topography. Groundwater produces karst topography. Winds produce aeolian topography. Sea waters produce coastal topography. And human beings produce cultural topography. Cultural topography. Out of these 7 topographies, one more you can add here. This is glaciers and meltwaters. And meltwaters, the ablated waters, ablated, ablated, ablated waters. And they produce which type of? This is glaciofluvial topography. Glaciofluvial topography, where we find drumlins, where we find the outwash plains, recessional moraines, the debris of stones collected by the glaciers in the past. This is a very potential part from here we can come across a few questions into the prelims part. Teacher is going to repeat again. Running water, a river, fluvial topography, glaciers, glacial topography. All these are the agents of erosion, exogenetic forces, and each exogenetic force makes its own topography. Then we are having glaciers and meltwater, glaciofluvial topography. Ice sheets, periglacial topography. Groundwaters, karst topography. Winds, aeolian topography. Sea waves, coastal topography. Human beings, cultural topography. Now, this is what the exogenetic force is that we must understand it. Now, we are going to focus on the endogenetic forces. Let's draw the second part of the diagram. We are having endogenetic forces. What we have drawn earlier, exogenetic forces. Now we are drawing endogenetic forces. Now these can be divided into 2 parts. These are the diastrophic forces, slow forces, the slow forces, and the catastrophic forces. These are the destructive forces, and these are the sudden forces. And these can be divided into 2 parts, the earthquakes and the volcanoes. Will come one after the others. And the diastrophic forces can be divided into 2 parts. Aperigenic forces, and orogenic forces. These are called mountain building forces. These are called continental building forces. These are called radial forces. And these are called tangential forces. Radial forces. Somewhat like this. If the force is working like this, it's a radial force. If the force is working like this is the tangential force. One is the mountain building force, other is the continental building forces. First, we are going to come on earthquakes and the volcanoes, the sudden forces, the destructive forces. We are moving to the next page. You have to come down under the volcanoes, right? These volcanoes, on the basis of periodicity, on the basis of explosivity, on the basis of three types: active volcanoes, dormant volcanoes, and these are the extinct volcanoes. For example, we are having Narkandam, Andaman Nicobar. We are having Barren Island, not Barren, Baratang Island. And we are having Barren Island, the active one, the Barren Island. All are the part of the Andaman Nicobar group. On the basis of explosivity, we are having several types. We have several types. Several. What are those types there? On the basis of explosivity, we are having Icelandic type, very quiet. We are having Hawaiian type. This is again very quiet. It's a flood lovers. When they come and surround us, we do not know. No explosivity, no noise. They're not vociferous. They're not noisy. Then we are having Strombolian type. Then we are having Vulcanian, Vesuvian. We are having Pelian. And then in the last, we are having Plinian. When Plinian type of volcanic eruption takes place, half of the earth hears the explosion and the volcanic cone is completely, or you can say maximum, collapses. So these are the most vociferous Plinian type. Why we are not giving much focus here right now? Because this is a separate topic. We are focusing on the forces. Volcano is a sudden force. Earthquake is a sudden force. They are responsible for the relief change within seconds, within minutes. Now let's come to the earthquake part. Earthquakes. There are several types that we can classify the earthquakes, but we are picking up only the two types over there. First one is on the basis of depth of focus. This is Earth from where the volcanic seismic activity, earthquake activity starts. That is focus, hypocenter. seismic center, where it hit first, that is epicenter. Now, the very first classification of the earthquakes is on the basis of hypocenter and the epicenter. How deep is the focus, the hypocenter? Focus or hypocenter or seismic center? Seismic center. 4 parts. This is shallow earthquake, normal earthquake, intermediate earthquake, deep earthquake. This is less than 10 kilometers, the depth of the focus from where the earthquake activity has started. 10 to 70 kilometers, 70 to 300 kilometers, and more than 300 kilometers, but less than 800 kilometers. On the basis of focus, on the basis of depth of the point from where the seismic activity started, the P wave and S wave started, the body wave started. Now come to the second one, on the basis of distance from epicenter. We have 3 types of earthquake. Distance is 0 to 110 kilometers, 110 to 1100 kilometers, more than 1100 kilometers. This is local earthquake. This is regional earthquake. This is tele earthquake, dur wala earthquake. I told now this diagram will come on the 2 pages. It's just like the Chinese conundrum, a box in the box, another box into the box, another box into the box. So this diagram is nothing but the entire syllabus of your geomorphology. Now let's come back. पीछे देखिए अब हमने कहां पर पहुंचना है. We have to see the diastrophic forces, orogenic and epeirogenic, mountain building and the continental building. You divide the orogenic mountain building into 2 parts and epeirogenic into the 2 parts. Divide it into the two parts. This is mountain building forces, tangential forces, divided into 2 parts. These are the compressional forces, and these are the tensional forces. Compressional, tensional. Tension forces into 2 parts, fractures and faults. Fracture on one side, fault on other side. FAULT, fault on the other side. Same way, compression forces are divided into 2 parts. First one is fold, other one is warp. We have 12 types of folds, we have 12 types of faults, which we'll do afterwards. Now we come to the epeirogenic forces, the continental building forces into 2 parts. Just the last part of the diagram, upward movement, upward epeirogenic forces, upward movements, and the second is downward movements. With the upward movements, we are having the continent building, and with the downward movements, we are having epicontinental seas, the water bodies. So this epeirogenic continental building forces can be divided into 2 parts, the upward movement and the second is downward movement. Now let's recall one after the other, one after the other. See, bache, this was the geomorphology definition we have done. Forces, we have just drawn the diagram of the forces. What are these forces? Let's see. What are these forces? We said in the definition of geomorphology that the landforms on the surface of Earth occur in patterns, and these are an outcome of the interaction of exogenetic and endogenetic forces. That's what we have done. Exogenetic and endogenetic forces. These exogenetic forces जो बाहर वाली हैं, अर्थ के सरफेस के ऊपर हैं, two reasons. एक टेरेस्ट्रियल जो धरती के ऊपर पैदा हो रही है, एक जो बाहर से आ रही है. बाहर से क्या आ रहा है? मेटेराइट्स, मेटेराइटिक ऐश जो स्पेस से आके गिर रही है at the rate of 10 kg per second. Our Earth is turning out to be heavier day by day. Terrestrial exogeneric forces are of 8 types: river water, rivers, fluvial topography, glaciers, glacial topography, glacials and the meltwater or the ablated water, ABLATET. That is the fluvioglacial. Fluvioglacial. Right? And then we have the ice sheet. This is the periglacial, PERI. Groundwater, karst topography. Winds, aeolian topography. Aeolian topography. Sea waves, coastal topography. Human beings, the cultural topography. Then we had picked up the endogenetic forces. 2 parts: diastrophic, slow; catastrophic, very destructive. Catastrophic, destructive, sudden. 2 parts: volcanoes and earthquakes. And epirogenic are of this diastrophic are of 2 parts. Epirogenic means, epirios means continent, oros means mountain. Mountain building forces or the tangential forces. Continental building forces or the radial force. This is a radial force, that is the tangential force. Now let's see how we have divided the volcanoes. We have divided volcanoes on the basis of periodicity and explosivity. Periodicity, 3 parts: active, dormant, extinct. जिनके नीचे का जो मैग्मा चैम्बर है खाली है, मैग्मा चैम्बर भरा हुआ है, एक्टिविटी नहीं है. मैग्मा चैम्बर भरा हुआ है, एक्टिविटी चल रही है, फ्यूमरोल्स नजर आ रही है, फ्लो ऑफ लावा नजर आ रहा है, मैग्मा लावा बनकर बाहर एक्सपोज होकर निकल रहा है. एक्सप्लोसिविटी, कितनी जोर से आवाज करता है, और भी बहुत सारी क्लासिफिकेशंस हैं, हमने जीएस के हिसाब से किया है. आइसलैंडिक, सबसे क्वाइट, सबसे शांत. हवाईयन, स्ट्रोम्बोलियन, वल्केनियन, वेसुवियन, पीलियन, प्लाइनियन, सबसे जो है ज्यादा आवाज करने वाला, मोस्ट वॉसिफरस, धमाके से बोलने वाला, आदि धरती को सुनाई देता बच्चे. Earthquakes on the basis of depth of the focus, from where the P wave starts, S wave starts, seismic wave starts, the body wave starts. They start from here, hit the epicenter, then they start moving over the surface as the L waves and cause destruction. L waves cause destruction. The surface waves cause destruction. Now see here, on the basis of this focus, hypercenter, seismic center, how deep it is there. Less than 10 kilometers means very shallow, very troublesome earthquake. Simple सी बात बचे, destruction is inversely proportional to depth of focus. जितना deep होगा उतनी कम destruction होगी, ज्यादा depth कम destruction. Shallowness of the focus, more destruction. ठीक है, नॉर्मल अर्थक्वेक 10 to 70, intermediate earthquakes 70 to 300, and then 300 to 800 kilometers are the deep earthquakes. जितना earthquake deep होगा उतनी कम destruction होगी. Distance from the epicenter, this is the surface of earth. At this point, these are the latitudes, longitudes. एक पर्टिकुलर पॉइंट के ऊपर आपका earthquake जो है वो हिट किया है, एपिसेंटर सरफेस से निकला, जो है इंटीरियर ऑफ द अर्थ से निकला और सरफेस के ऊपर पहुंचा, जहां पे हिट किया, वहां से 110 किलोमीटर की डेप्थ तक, जो है रेडियस तक, 110 से 1100 किलोमीटर की रेडियस तक, और फिर जो है मोर देन 1100 किलोमीटर, वो टेली अर्थक्वेक है. 110 से 1100 किलोमीटर वो रीजनल अर्थक्वेक है. 0 से 110 किलोमीटर वो आपका लोकल अर्थक्वेक है. You will feel more the local earthquake than the regional and the cherry earthquake. Right बच्चे, वापस आते हैं. डैश फोर्सेस के ओरोजेनिक फोर्सेस को, माउंटेन बिल्डिंग फोर्सेस को हमने दो पार्ट में डिवाइड किया, कंप्रेशनल, टेंशनल. टेंशन फोर्सेस में दो चीजें बनती हैं आगे, फ्रैक्चर, फॉल्ट्स, FAULTS, फ्रैक्चर्स, FRACTURES, और कंप्रेशन फोर्सेस में बनते हैं फोल्ड, वार्प. फोल्ड कैसे होते हैं? लाइक दिस, दीस आर द फोल्ड्स. वार्प्स कैसे होते हैं? वेरी जेंटल. फोल्ड्स आर बिट शार्पर. और जो एपिरोजेनिक फोर्सेस है, कॉन्टिनेंटल बिल्डिंग फोर्सेस है, रेडियल फोर्सेस है, टू पार्ट्स, अपवर्ड मूविंग फोर्सेस, डाउनवर्ड मूविंग फोर्सेस. With the upward moving forces we are having continents, and with the downward moving forces we are having the epicontinental seas or the water bodies. This is for today. Tomorrow we will repeat it, but that will be the offline class. Take care. If everything goes fine, Pakistan does not go mad once again and starts throwing, shooting the projectiles on us, we will be having the offline class. Everything will be fine. Thank you, Vachi.